And welcome back to the next part that's looking at integration and its applications. In this video, we're going to now look at finding the exact value of the area under a curve when the area turns out to be below the x-axis. So we've already looked at approximating and areas above the x-axis. So the next part is to look at areas below the x-axis. So for this question, we're going to find the region that's fully enclosed by the curve f of x and the x-axis, which means we're finding the area between -1 and 2, which is this region just here that I'm shading in. So we knew previously that we could calculate the area as being equal to the integral between a and b for the function's rule f of x dx. And now when the area is below the x-axis, we need to do one of two things. And in fact, there's a third one if you know what the modulus function is, but I'll leave that as another video for another time. So the two things we can do to make up for the fact that the area is below the x-axis, because what that will do to our integral value is it will make it negative. So we need to make it positive in some way. So we can add a negative sign out the front of the integral. Or the second thing we could do, and you don't have to do both of these things, only one or the other, is you can swap terminals. So that means you could do from B to A instead of A to B. So for this video, we're going to have a go at that second method. So for this question, we know that our area is going to equal, and we're going to have the integral, but instead of going from -1 to 2, we're actually going to go from 2 to -1. So that means we've swapped the terminals, which will go from a negative value for that integral that would have been from -1 to 2, and this integral will now be positive, which is what we need for an area. So we're going to go from 2 to -1 for the function's rule, which is x cubed minus 3x minus 2, and we're going to evaluate that with respect to x. So to evaluate this, we know that we can calculate the antiderivative. So x to the power of 3 will add 1 to that power and become x to the power of 4, and then divide by the new power of 4. And then we'll have minus 3x, and adding 1 to this power will give minus 3x squared, and then dividing by the new power of 2. And then minus 2, which is a constant, will just become minus 2x when we calculate the antiderivative. Then we're going to go between 2 and -1, so we'll just put those values here. And we know that we have a theorem that will allow us to evaluate that. And that theorem is we take the antiderivative and substitute the upper terminal, in this case -1 in, and then we subtract away the antiderivative with the lower terminal of 2 substituted in. So that's what we're going to do in our next line. So substituting -1 into here, we will have -1 to the power of 4 divided by 4, and then we have minus 3 times -1 squared over 2, and then we have minus 2 times -1, and then we subtract away from that the antiderivative with 2 substituted in. So we're going to have 2 to the power of 4 divided by 4, and then we're going to have minus 3 times 2 squared over 2, and then we're going to have minus 2 times 2. So cleaning that up is our next step. So we're going to have -1 to the power of 4 is positive 1 over 4. And then we're going to have -1 squared here will become positive 1. So we're going to have minus just 3 over 2. And then this is going to be -2 times -1 gives positive 2. And then we're going to subtract away from that. And here we have 2, 4, 8, 16 over 4, which just gives 4. And then we have minus, and this will be 12 over 2 is 6, so minus 6, and this will be minus 4. And now simplifying this, we'll have 1/4, and getting a common denominator, this will be minus 6 on 4. And then we're going to have plus 2 still. And then over here we have 4 minus 10 is minus 6, but taking into account this negative, we have plus 6. So inspecting what we found there, we have 2 plus 6 is 8, and then we're going to minus a total of 5 over 4 away from that, which gives 27 over 4 in total. and we could write that as units squared. And now if you're interested, that decimal would also be exact, and it would be 6.75 units squared. So that is the area of the shaded region, which was the area enclosed by the graph of f of x and the x-axis. So once again, I do hope that this video has helped. Stick around for the next part in this series, which is going to look at mixed areas, where we have some area above and some area below the x-axis. And make sure, if you want to see any more videos like that, you check out the ones that are listed in the description below. So once again, I hope this has helped, and stick around for the next video.